Hello geniuses! Welcome to Vidwath Academics. I am your math tutor Devika. Today we'll be studying a very interesting concept in class 9 mathematics called Heron's Formula. What is Heron's Formula? Let's see. The area of a triangle is given to us by the Heron's Formula. In our previous classes, in our lower classes, we have studied how to find the area of a triangle. The most common formula that we have studied is area of a triangle is equal to half into base of the triangle into height of the triangle. That is, if I consider the above triangle, then the base of the triangle here is given by C and the height of the triangle is given by H. On substitution of C and H in terms of B and H, I get the formula or I get the value of the area of this triangle. But there was a Greek mathematician by the name Heron. He is also known as Heron of Alexandria or the hero of Alexandria. Let's not go into the history of why he is called the hero of Alexandria, but we need to know the formula that he has given us or the formula that he has formulated. That formula is called the Heron's Formula. It is named after his own name. What is Heron's Formula? Heron's Formula gives us the area of the triangle in terms of the sides of the triangle, or Heron's Formula gives us the area of the triangle in terms of the lengths of the triangle. In our previous classes, whenever we are given triangle ABC, say with lengths 3, 4 and 4 centimeters. To find the area of this triangle, we would draw a line from A to B, that is an altitude, in order to find the height of this triangle, and then we would multiply the height with the base and divide by 2 to get the area. But by making use of the Heron's Formula, we can avoid the extra step of finding the height of the triangle. So, what are we going to make use of in this formula? You can see terms S, A, B and C in the formula. Here, A, B and C are simply the lengths of the sides of the given triangle. A is the length of one side, B is the length of the second side and C is the length of the third side. But what is S here? The S is nothing but the semi-perimeter. What do you mean by semi-perimeter? We know the perimeter of a triangle is nothing but the sum of the lengths of all its sides. The semi-perimeter of a triangle is nothing but half the perimeter of the triangle. If the sides of the triangle are given by A, B and C, then the perimeter of the triangle is sum of the lengths, which is A plus B plus C. So what is semi-perimeter? Semi-perimeter is half the perimeter, that is perimeter divided by 2. Therefore, our semi-perimeter S is equal to A plus B plus C divided by 2. This is our semi-perimeter. Now, in the formula, the area of the triangle is given by square root of S, semi-perimeter, into S minus A, into S minus B, into S minus C. S minus A, S minus B and S minus C are nothing but the differences of the semi-perimeter and the lengths of the sides of the triangle. Now, this is our simple formula using which we can find the area of the triangle. Now, let us see how we can make use of the formula to find the area of triangles. Now, look into the first question. A traffic signal board indicating school ahead is an equilateral triangle with the side A. Find the area of the signal board using Heron's Formula. If its perimeter is 180 centimeters, what will be the area of the signal board? This is the signal board that we have and it has school ahead written on this. You must have seen such signal boards near your schools. Now, this signal board is of the shape of an equilateral triangle. What do you mean by an equilateral triangle? All the sides of this triangle are equal to each other. This triangle is an equilateral triangle. Now we need to find the area of this equilateral triangle by making use of the Heron's formula. It has been given to us that the side of this equilateral triangle is A, or A centimeters, or A meters. So let us not dive into the units of this triangle. So we'll just take it as A. We know the Heron's formula is given by area of triangle is equal to square root of S into S minus A into S minus B into S minus C. Now we need to find S. S is the semi-perimeter. In this case, S will be given to us by sum of the sides divided by 2. Since each side is A, the sum of the sides, that is the perimeter, is A plus A plus A. So semi-perimeter will be A plus A plus A divided by 2. Therefore, S is equal to A plus A plus A gives us 3A divided by 2. Now this is our semi-perimeter. Now let us substitute the semi-perimeter into our Heron's formula. So we get S is 3A by 2 into S is 3A by 2 minus our A is A itself, which is one side of the triangle, and 3A by 2 minus B. B is the second side of the triangle, and since this is an equilateral triangle, B is also equal to A. And S minus C is given to us by 3A by 2 minus A again, since the given triangle is an equilateral triangle and therefore all its sides are equal, is equal to square root of 3A by 2 into, look at the three terms here. Aren't all these three terms the same? 3A by 2 minus A, 3A by 2 minus A into 3A by 2 minus A. We know that if we have B into B into B, that is the same term or the same variable or same constant multiplied with itself 3 times, then we can write this as B cube, isn't it? Similarly, let me write these 3 terms. Let me write the product of these 3 terms as 3A by 2 minus A whole cube. Now let me simplify. So I get this as square root of 3A by 2, open brackets, we have 3A by 2 minus A. Now I will take 2 as the common denominator. The first numerator will remain as it is since it already has 2 in the denominator. Since the second term has a denominator as 1, in order to take its denominator also as 2, I am going to multiply 2 here. So I get minus 2A. I am sure you have all studied how to add or subtract fractions in your lower classes. I am simply making use of that concept. And we have the power as 3. Now let us simplify. This will give us square root of 3A by 2 into, open brackets, 3A minus 2A gives us A by 2 cube. This is equal to square root of, now can I write A into A cube as A power 4? Isn't it? A into A cube, that is A is multiplied with itself 4 times and hence I am going to write as A power 4. I will write 3 as it is divided by, I have 2 cube. 2 cube is 2 into 2 into 2. 2 2s are 4, 4 2s are 8. 8 into 2 gives us 16. Now we know that 16 is the perfect square of 4. Also, A power 4 is also a perfect square. It is the perfect square of A square. How is that? A power 4 can be written as A square into A square. Therefore, I can take A power 4 outside the brackets and write it as A square, and I can take 16 out of the bracket and write as 4 into, I only have 3 within the square root. Therefore, I can write A power 4 outside the square root as A square divided by, I can take 16 outside the square root and write as 4 into root 3, since 3 is remaining under square roots. So this is equal to root 3 by 4a square. Be careful, this root applies only for the term 3. Now what you see here, root 3 by 4a square, it is the formula for the area of a triangle where a denotes all its sides. That is, this is a formula for an equilateral triangle of side A. So that finishes the first part of the question. That is, we have found the area of the signal board using Heron's formula. This is the general area formula. Now, a particular case where the perimeter is given by 180 centimeter. The perimeter is given by 180 centimeter. We know that the perimeter of an equilateral triangle is given by a plus a plus a, which is nothing but 3a. Since the perimeter is 180, let me substitute it in place of p, and I have 180 is equal to 3a. From this, I can write a is equal to 180 divided by 3, which is equal to 60 centimeters. So I have the sides of the equilateral triangle as 60 centimeter. Also, they have asked us to find the area in the case where the perimeter is 180 centimeter. Therefore, our area will be equal to, we have seen in the previous case that area of an equilateral triangle is given by root 3 by 4 a square. So, area is root 3 by 4 a square. In place of a, I will substitute 60 centimeters. That is, I have root 3 by 4 into 60 square, which is equal to root 3 by 4. 60 square is nothing but 3600. Why? Because 6 square is 36. We have 0 here under square root. So, I'll write 2. We have 0 here within square. So, when I take the squares, I'll write 2 zeros next to 36. I can further simplify this and write 4 1 times. 4 9 times is 36. Write 2 zeros. This will give us 900 root 3 centimeter square. Always remember, whenever we are finding the area, we must write the units as either centimeter square, meter square, kilometer square. That is according to the units that is given in the question. Now we have seen how to solve a problem of area of a triangle by making use of the Heron's formula. We shall be solving more such problems by making use of Heron's formula in the following sessions. Until next time, do not forget to subscribe to our Vidwath app. You can also follow us at all these social media platforms. Remember, to be the best, choose Vidwath. So until next time, keep studying, keep practicing, keep learning and enjoy math.